Hi, buddy. This is Dr. Dan, and I'm back with one extra bonus video about PCB design that we have recently learned some things and had to make some updates. And so what happened was we were able to design PCBs in the past. I ordered them from PCBWay, as I've shown you. We've never had a problem, but recently we have not been allowed to order from a Chinese company, so we've had to find an American company. And unfortunately, the American company we used had some manufacturing defects despite the PCBs being designed correctly. And so we have learned some things, and I wanted to give you updates on how to avoid those manufacturing defects. And so the problem would be like when we zoom in here, like this trace that's on the board was really close to like the pad, or like down here, these two blue traces are really close to each other. And so what would happen is we would expect that those aren't connected electronically, and in the past they haven't been. But when we ordered from this American manufacturing company, it seemed like they were, because when we checked continuity between like that pad, it said they were connected, even though they weren't. And so clearly something was going on with the manufacturing, probably had to do with the fact that these traces and pads were really close to each other. So we'd like to avoid that. I just want to point out a couple other things that we learned in the process. One of the things that I think is pretty cool is you can actually see the names of all the traces, right? And so like this is our negative power, and so it's labeled V minus, and it goes to our V minus pad. So we can follow that all along. And so if you're ever concerned that like some traces are touching each other, you can always look and make sure that they have the correct label on the traces themselves. So we can zoom way in and you can see the, the traces, right? And so this one's N$3, and so that's not touching N$2, right? And there's N$6 down here, so those are all not touching. And so you just want to make sure that the things that are supposed to be like this V minus is going to the correct place. It's also connected to this one that's labeled V minus. And so we feel pretty good about that. There's also the ground. The ground ones are labeled 0. So let's see where we can find ground here. One place is the instrumentation amp, right? Has a ground pin right there. And so all these that are labeled 0 are going to ground. So that's one additional check you can do to make sure that the routing is not screwed up by zooming way in and looking at the individual traces. Okay, but we have to go back and solve our original problem, and we want to make sure that our traces are not too close to each other. And so what happens is when you do the auto router, it's following a certain set of design rules. And so we can change those design rules by going up to the rules section here. And under rules, there's design rules. Right? And so it tells us all these wire clearances is 6 mil, wire pad clearance is 6 mil all the way through, right? Mil is 1/1000th of an inch. So this is 6/1000th of an inch, which is really close. And so, apparently 6 mil is too close for these manufacturing. So we're going to make them bigger. I don't know what the right number is, but our design is not really that compact. Like we're not trying to squeeze a lot of components in here. So I don't know that it matters that we have it very close. So I'm just going to choose, maybe we'll go 4 times that and make it 24 mil. And so I'm just going to take that, I'm going to copy and paste it to all these other clearances. We don't have any SMD, so it doesn't really matter, but I'll leave it there. Drill clearance, I guess we'll make that too. Some of this other stuff we probably don't need to mess with. Copper width, we'd still think 6 mil is pretty good for that, because then you're just adding more copper, which will make the board more expensive, which is not what we want to do. Okay, so let's try that. So I set my new design rules up. We're going to go back to design, unroute all, right? We want to get rid of all our routes. And so now we're just left with these air wires again. And so now let's go ahead and use the auto router. We'll go ahead and continue and start. I'll just choose this one. And now we can look at our PCB again. You can tell we still have plenty of room on the PCB, and none of these wires are close anymore, right? It's still kind of making this loop around, but there's a lot more space. So that's much better for us. And I think this will work better. Again, I don't know what the minimum number you should use is. There's no reason to be super tight in our design. The other things I wanted to point out, if you're interested in spacing, you can also look at the grid. So you can turn on the grid that says grid size is 50 mils, again, 50 thousandths, and you can display it if you really wanted to. And so you can just see how things are spaced out, and you can move things maybe around on the grid to help you kind of visualize and space things out if you wanted to be, really perfectly spaced. The other thing is this American manufacturer actually charges by board area. And so in the past, I didn't really care as long as we went to PCB way and it was less than $5 to manufacture. I was good with that. This American manufacturer, they literally charge by square inch. And so I am going to limit your board dimensions. If you want to know how big your board is, it's over here. And so this is 1.26 inches by 1.78 inches, 1.79 inches. And so that's how you can calculate the area. Again, that's it. It's in mils, so it's thousandths of an inch. But by making that design change and giving more space between all the wires and the pads, we'll be able to have a much more successful design that hopefully the manufacturer will be able to handle.